Gaze generation for avatars using generative adversarial networks. A conversational avatar does not only need to be good at talking, but also exhibit some realistic behavior. Avatars that don't use their eyes naturally look either weird or scary. Extreme examples are constant staring or relentless eye rolling. We evaluated 5 different models to generate gazes for avatars. 3 of which are procedural models and 2 are based on generative adversarial networks. For each of the models, we differ between a speaking and a listening mode, as eye movements differ between those 2 states. The ieee model is based on dataset statistics reported in a scientific paper from 2002. It is characterized through long direct staring, interrupted by briefly looking away, which results in a starburst-like shape of the gaze map. Similarly, the Dembinski model relies on the statistics reported in a recently published dataset on eye movements during conversations. It is missing constraints on the position to look at, leading to the gaze wandering off. The Fuse model combines the previous 2 models, using ieee for the macro movement and Dembinski for micro movement. This leads to a starburst pattern enriched by additional smaller movements, avoiding the impression of staring. The generative adversarial network models are directly trained on the provided dataset. The first uses a convolutional neural network with windows extracted from the data. It generates movement that wander around but always tend to come back to the center. The second deep learning model uses a recurrent neural network and consumes the data directly. The produced patterns are reminiscent of a Gaussian distribution, with most fixations scattered around the center. Comparing the generated data to the ground truth dataset, the gaze maps created by the machine learning models look more reasonable. We focused on several descriptive metrics, such as fixation duration, saccade magnitude, and saccade direction. To evaluate the naturalness of the generated gazes, we set up a user study, where we let participants compare 2 avatars side by side. We exclude the Dembinski model due to its bad performance. Each participant sees a total of 3 rounds: speaking, listening, and dialogue. In each round, all models are shown in pairs, resulting in 6 pairings per round. This makes a total of 18 comparisons per participant. We collected feedback from 73 participants, resulting in a total of 1,314 pairwise comparisons. We calculated the aggregated approval rate per model and found that most participants preferred the Fuse model, followed by our GANs, and with the ieee model last. The CNN is better than the RNN, due to its higher stability provided by fixed windows during training. The GANs were not able to rank best, but outperformed the current baseline, which is already 20 years old. Currently, the GANs only take into account the conversation mode, speaking or listening. Future models can incorporate the associated speech directly, making them superior to any procedural model. Thanks for watching and stay tuned for future research.